Hello, Mrs. Kanemoto here, and let's go over how to solve a final programming project like this one here. Let's read through the directions. The data that is given to you is a text file called carmpg.txt. Remember that I have another video on how to download and load this type of file into Eclipse. You should watch that video and load this text file into your project in Eclipse. It's a file that has the miles per gallon listed for a car and then the car name, division, and car line. That text file looks like this. Remember that when we solve this problem, we'll need to make at least one function, and we can make this function to solve any part of our problem. Our first step is to read in the data from this file into two arrays. These are called parallel arrays. The first array is to hold the first item on each line, which is the miles per gallon for a particular make and model of car. The second array is to hold the rest of the line of text in that row and is the make and model of the car, as you can see. Remember that the information in both of these arrays at parallel indices are correlated. Remember to have this visual of what an array is and this visual of what your parallel arrays look like. That's our first step. Read our data into our arrays. So let's complete that step. Here's what our data looks like. Let's see. First, think how we're going to read this data in. We'll need an array of doubles to hold this part, our miles per gallon. Remember that when we read our data in, it's going to read up to the end of the 0.5 and pull that data in and put it into our array at index 0. Then we'll ask our program to read in the rest of the line of text. It'll read in that white space and the name of the car. Remember then that it takes this data and loads it into the second array, and we'll have this array be of type string to hold all of our car names. Remember that the cars at index 0 are related to each other. When we read in the car for index 1, we'll read his miles per gallon into our array for doubles, and we'll read the next car's name, including that white space, into our array of strings. Alright, let's do this. So first we need to make a new class inside of Eclipse. Remember to name your class with a capital letter. That's a Java standard. You can also check mark to include main. Remember to write your name and date at the top of your programs. This is also a Java standard. Remember to change this automatic comment into something that actually makes sense. Now the first thing we need to make when reading in some data is a scanner object. Now we have used scanner objects in the past to read data from our console window. So you should be familiar with the syntax to create a scanner. Now instead of our scanner connecting to system.in, how we normally write it, we want to connect our scanner object to a file object. A file object that's going to be our file. So we'll need to create a file object with our file class. And in the constructor of our file class, we'll put the name of our text file exactly as we've written it, including the file extension. Remember that if you spell this name wrong, your program will not be able to find that text file. Now I'm getting some red underlines because I need to import these classes. So I can hover over that class name in Eclipse and choose the first quick fix which imports that java.io file class so that I can use this pre-written code. Let's go ahead and import our scanner class as well using that quick fix. Alright, now instead of system.in, I want my scanner object to connect to this file object. So I'll put the file's name there. Now immediately I get another error. And if I hover over that error, it tells me that I have an unhandled exception type for file not found exception. Exceptions are a really great thing inside of programming. Exceptions allow us to recover from failures that happen in our code. Think about if you read from a text file and that text file was not there. The rest of your program would not run correctly, and it would crash. So, they put fail-safes inside of Java, and these are called exceptions. When something could fail, that something, or that opening of the file, throws an exception. Your program has to take care of that exception. They make you take care of this exception. But it is a good thing. When you take care of this exception, with either of these two quick fixes, you can allow your program to recover from failure. Let's see here. We're not going to throw our declaration. We want to use the second quick fix here, which says surround with a try-catch block. Note that it puts our scanner object inside of this try-catch block. We need to move this declaration, so I'm Control-C or copy that line. And we need to move his declaration outside of the try-catch block so that we can use this object outside of that try-catch block. But then we put the instantiation inside of the try-catch block so that it can catch that exception. Now, if this part of our code does fail and it does not find this file, this part of our code will catch that exception. So this part of our code is only run if this fails. So you write what you want your code to do right here if that fails. All right. The default thing that Eclipse does when your opening of your file fails is just print out this error message or this stack trace. You can leave that, and you can also print out to yourself in the system output window a message. Then, if you don't want your program to continue on anymore, you can stop your program from running. Now, this is not the most elegant way to recover from not finding a file, but in first level programming, this is okay to program something like this, when you just output your error message, output a stack trace, and then just end your program. All right, let's go ahead and put an error message over here so we can see what happens if it does find it. Let's try this code out just to see how it works. Let's go ahead and spell the name of our file incorrectly, so it's not going to be able to find that file. I'll go ahead and compile and run my code, and I do get that error message and that stack trace where Eclipse is telling me that it did not find the file, and there's my stack trace. And then it ended my program. Now let's spell the file name correctly. Now it should find the file. So if I run my code, you can see that it skipped the catch part because it did not fail. And it went ahead and continued on with my programming code and wrote file opened. Well, we have success in connecting to our file now. Now let's read some text from it. Now when reading from a text file, a lot of times you don't know how large that text file is. You don't know how many lines you are going to read in. So when reading from text files, most of the time we're going to use a while loop because we don't know how many times we want to iterate or read from that file. The control for our while loop is a method from that scanner class. There's a method here called hasNextLine. This method returns a Boolean, meaning it returns true or false. It returns true if there's another line in the input, and returns false if there's no more lines. Therefore, this is the perfect method to use. It'll return true and keep our loop iterating while there's more input in our file, and when there's no more input to be read in, this method will return false and will exit our loop. Remember that you can name your curly brackets down here as you start to accumulate them so you don't get confused about where to put the rest of your code. Now, this loop will happen as we're reading in lines from our file. Let's go ahead and read a line in from our file. We'll read the whole line into a string variable we call line. Remember that when reading input or doing anything with our scanner object, we're going to use a scanner method. So we put the name of our object, the dot operator, and we look for the line or the method that we need. Next line, we know how to use next line. Remember that next line reads in a line of text up into the end of line character. So it's going to read in this entire line and put it into that string variable called line. Let's then just print them out. Alright, this will read in a line from our file and print it out. Not doing that much yet, but it's a good test. Alright, we'll go ahead and run that code. And voila, we reached the end of our program. And we read in all of those lines. Now another very good thing to do when reading from files is to close that file, or close that scanner object. So at the end of your program, after you're done reading from that file, remember to close that file, or close that scanner object. Alright, now we need to read our data in not just into a string, we need to read it into our arrays. So first we need to make our two arrays. Now the problem with reading in from files is that a lot of times we don't know how many lines are in the file. Therefore, we don't know how large to make our arrays. Now in our first level programming course, I'm going to tell you how large to make your arrays. We'll go over later on how you can tackle the problem of not knowing how large to make your array. Let's go ahead and make our double array 722 doubles long. And we made it that length because our text file has 722 records inside of it. That means that we need to make our parallel array of our car names also equal to a string array that has 722 variables. Remember that these arrays are related, so they have to be the same length. Alright, now we need to read our data into our arrays. Now to do this properly, we need to make a variable, let's call it count, and initialize it to 0. We're going to use this variable as our indice inside of our arrays, and it'll also keep count of how many cars we've read in. Alright, let's go ahead and read in that double first. So we're going to use our scanner object, and we want to read in the double. So remember that we know this method. We've been using this method all along. Next double reads in a double from our input. Now we want to put that double into our array at the proper indice. So we'll access our miles per gallon array at index count, which starts out at 0, and load that double into that array. Great. Now we want to load the rest of this line, including the white space, into our array called car. So we'll take that next line, which will read in the rest of that line, and put it into our car array at the same indice. Now importantly, we need to increment our count so that the next variables we read in from our text file will be placed at the next indice. And voila! We are reading our data into our arrays. Now to see that this is happening, and to make sure it's happening, let's go ahead and make a for loop and print out the contents of these arrays. Remember that your for loop always looks the same way with arrays, and when working with parallel arrays, you can use the length variable of either of those arrays. So we'll just system out print line, the MPG at that index, and then the car name at that same index. Alright, let's go ahead and run this code. we can see, yes, it did read in those variables, put them into our arrays, and then it printed out those arrays. Alright, now let's continue on with our programming problem. We're supposed to find the car with the least amount of miles per gallon and print this car out, and then find the car with the highest miles per gallon and print this car out. Alright, let's go ahead and do that. Remember our max and min algorithms. Remember, for the max algorithm, you can set max to a really small number so something can be bigger than it, or set it to the first item in your array. For your max algorithm, what you do is you compare each item in your array and see if it's greater than the max. If it's greater than max, then it becomes the new max. Remember that your min algorithm is very similar to this. You compare every item in your array and see if it's less than the min. If it's less than the min, then it is the new min. Remember now that outside of my for loop, I can now print out my max and min. Now this will print out the max and min miles per gallon. I can run my code and see that this works. Now I also want to print out the car name. How am I going to know which car name had that miles per gallon? Well, there's two ways that you can tackle this. The first way is that you will just store the name of that car as well as that max miles per gallon. Remember that if you're executing more than one line in your if statement, that you'll need curly braces. Remember that the car name with the max is at the same indice as that car's mile per gallon at that indice. This is one way that you could store that car name, and then at the end here, print out the car name for that max as well. Another way that you can do this problem is to not store the min value, but to actually store the min index of where the min value was. So you would change your code and you would store that min index. You would then compare every value in your array to the value at that min index, and then instead of storing min, when you found a value less than that value, you would store the indice of that min value. Now I can access my array at that min index and know the miles per gallon and the car name at that min index. And I can see my cars with the most miles per gallon and the least miles per gallon. Now let's tackle the next part of this problem. We need to find the standard deviation for the miles per gallon of the cars. Alright, we know how to do standard deviation. Let's go ahead and make a method to solve this part of the problem. So we're going to make a method that will find our standard deviation given our array. Remember that in this class we make our methods public and static. We'll want to return the standard deviation, so we'll want to return a double. We can name our method something that it finds or does. And then in order to find the standard deviation, we need to be given our array of values. Let's figure out our standard deviation algorithm. Remember what the standard deviation is. Here's our standard deviation. We'll need to first find the mean, or the average, of all the miles per gallon inside of our code. So, to find that average, remember that we have stored our values in our array, so we're going to use a for loop to iterate through that array to find that average. So the first thing we need to do is find the sum of all of our variables. Remember, we can initialize sum to 0, and then add to the sum every variable in our array. Remember that we named our parameter array. Now it's yelling at me because it still wants that double returned, but you can ignore that for now. Alright, remember to find the average then. Remember then to find our average, we divide the sum by the array's length. Remember that you could do integer math here, but since sum is a double, we're okay. Now after we find the average, we need to find the sum of every value in the array minus the average, and then squared. So we need to have another for loop. Remember that you can't do this in the same for loop because you have to use the average inside of this for loop. So you had to find the average first. Now we can use that sum variable again, but if we use the same sum variable, we need to reinitialize him to 0. That way when we add our new values to sum, it'll be adding to 0. Now let's see. We need to take each value in our array, subtract that average, and then square it. Then add that to sum. This will be the top part of our numerator. Remember that we need to find that top part of our numerator before we do the rest of our calculation. Now, we need to take the square root of that sum divided by n minus 1. So we'll take that sum and divide it by our length of our array minus 1. Remember that for your order of operations to happen correctly, you need to have these parentheses. Also check that you're not doing int math, and since sum was a double, we're okay. This will find our standard deviation. Let's go ahead and test this. We'll send to it as an argument our mile per gallon array, our array of type doubles. We can see that it found the proper standard deviation. Now continuing on in our program, we need to print a table that will print out the cars that have miles per gallon that are within one standard deviation of the mean. Alright, let's do it. So back up here in main, now that we know the standard deviation, we can print out the cars that are within one standard deviation of the mean. So let's go ahead and make our second for loop. Now to find cars that are within one standard deviation of the mean, we need to know the mean, or the average. We found the average down here, but now we need the average up here. Now we could copy and paste this code up here to find our average, change our array name to miles per gallon, and this would be an okay way to do this. So now we can find that average. But whenever you start copying and pasting code like this should signal to you that you should encapsulate this code into a method so that you can reuse it whenever you need to find the average. So let's do that. Let's take this code. Remember to come outside of all of your other methods. Make this new method public and static. It's going to return a double for our average. And it's going to take as its parameter an array of type doubles. Now we can paste that code in here. And then, instead of just finding the average, let's return it. Now we need to change our name to 1. And now we have a function to find the average given an array of doubles. Now instead of writing this code up here, let's go ahead and call our method. We need to pass to it that array of type doubles. We had to redeclare sum because we got rid of that declaration. But our code should work exactly the same way, and we have the convenience of this method. Now when we need the average up here, we can just call our method. And of course send to it the miles per gallon array. Now, let's print out those cars that are within one standard deviation of this average or mean. Now let's go ahead and make a variable to hold our standard deviation so that we don't have to recall this method over and over and over again. That would make for very inefficient code because we'd be doing all those calculations multiple times. Instead, let's store the standard deviation in a variable so that we can use it here in our code. So if a current miles per gallon is greater than the mean minus the standard deviation, and that current value in miles per gallon is less than the mean plus that standard deviation, then we know that that car is within one standard deviation of our mean. And so we'll print that car's miles per gallon and that car's name. And voila! We have printed all of the cars that are within one standard deviation of the mean. Well, almost. In copying and pasting this code, I forgot to replace this indice here with I. And now we have printed all the cars that are within one standard deviation of our mean, and thus completing our programming problem. I've also created some convenient functions that I can reuse in my other programs.